Okay, so good morning. So good afternoon. Yeah, good morning. So let's try this question. So basically, this is the question that is the AQA mechanics part. So this is the for the further mechanics AQA. The first question that I'm going to discuss it. So the first question that state is shows that the sideways of acting on the platform, there are the two acrobats, basically the stuntmen. So as you can see, these are the two acrobats, the stuntmen. They are doing some kind of the stunt. So as shown in the diagram below. So if I try to explain, so they are the two aerobat. Each of the mass is 85 kg and suspended to the each of the rope and attached to the opposite edge of the circular platform, and that is at the top of the vertical pole, and the vertical pole has the diameter. So this is the basically this is the motor that try to spin these aerobats in this motion. So basically these aerobats are moving and something, so there is a motor, and the diameter of this motor, that is the 2 meter that they given, and these are the ropes. If you look at from the upside, so this is the view from the top of the this if you have your eyes are here. So if you are looking the observing from this side, so if your eyes are here, so then you can see this something like this. So they are the two acrobats, and from there, if you are looking from the top one. So this is the case that we have it. So let's try to. So this is the demonstration that they given here something. So the diagram. Now they have given some of the more information here. When the period of the rotation of the platform is 5.2 seconds, so means that the each aerobat to complete a complete round, so it is taking the means that period is given. So time period is given to us, so that is 5.2 second. The mass is given, so let me write all the given information. 85 kg, that is given on there. So, and okay. So the center of the mass of the each of the aerobat is 5 meter below the platform. So the center of the mass, what is that center of the mass concept is? Center of mass, COM, we call it, that is. So where the whole mass of the body can be concentrated. We consider to be, it is not actually. So just like this, my body, the whole mass of the my body to solve the problem, what we are going to be consider, that is somewhere inside the stomach somewhere. So the where the things get balance it out. So that is the center of the mass concept. So if I had to be, this is very easy that you can find out the center of the mass. So this is a scale, so that I have it, and to find out the center of the mass, what that the logic that we can apply, where that now this is not the center of the mass of the scale, so I have to put the finger where that the mass get balance it out. So basically, whatever the mass on this side, on the left side of me, on the right side of me, that get balance it out. This is the at this point there is center of the weight, basically that is the mg weight that is acting it downward, that have to be cancelled by the my normal applied by the my finger, so that the finger is applying the normal force upward, that is get balanced out by the mg force that is acting it downward. So this is the center of the mass. So the whole mass of the scale I can consider at the where I can balance it out. So every body has a center where you place it, at that point the mg force can balance it out. So that is the center of the mass or the center of the gravity, the point. So they are simply saying, mentioning that the center of the mass of these persons are 5 meter from the motor. So that is the 5 meter distance. So they have given the center of the mass of the each of the person, so even they have pointed out here. So this is the 5 meter that they given. So, and the angle, what is that angle is 28.5, that is making with this one, the rope is making this much to the vertical as shown in the figure. Show that the linear speed of the acrobat is about 2.5 meter per second. So to find out the linear speed, so the linear speed you can easily find it out. So just think it like this. For the linear speed, just if I if I go to this free body, so let me try to make it. Okay. So the thing here is that we can consider. So this is the thing. Okay, so let me make it for this person only. Just think it like this. This person are spinning, correct? So these both are spinning. So for a moment, we are going to be take the one of the person. So they are spinning like this. So they are rotating like this basically. This is the one kind of the rotation that is happening over there. Something like this. So if I had to show you, okay, so something the ball here, that is the same case that the one of the person that is doing. So for that one, so let me stop it. So if I can stop it here. So okay, so let me make it slow. And okay, so this is the case right now. This is the person. You can think it like this. So, but this the angle is the different that they made it. So this is 28 something, 28.5, and our target is to find out the whatever the speed, linear speed. So I'm going to write with the v. So the linear speed, how we can calculate this one? In this case how we can calculate? So this is the circular motion. So as we know that the linear speed is, we can find out the speed is the how much the distance is traveled, distance by time, that you can calculate easily. How much distance it is? So the distance is this, the circumference of a circle. So you can think it like this, through which it is moving in a one cycle. So that is, and for that one I had to find out the r is the radius. So in this case, you can easily find it out. So in this case, so the R, this is the 1 meter, but in that question, they haven't given the 1 meter, they have given the vertical line. But for this one, the speed, distance by time. So I'm moving to the further to the same question that we had to do, but this is the case right now. I will come back again to this figure because this is the better demonstration. So right now, so we had to be somehow find out the these how much that total distance is being covered basically, that the distance you can find it out if I had this radius, the complete radius. If I had this complete radius, I can find it out. To do that one, so to do that one, this is the 2 meter. So I can easily calculate this is the half of that one, so this is 1 meter. And then I know the this 5 meter. I know this. Let me raise this one for a moment. This is the 5 meter, and this is 28. So let me make it here. This is 5. This is the 5 meter. And just let me know which trigonometry formula you're going to use it to find out this, because as I get this distance, let me call it this is x. And I am going to add with the 1 meter, and you will get the total radius. So this, to find out this x value, I can use opposite is known to you. Opposite we had to find it out, and the adjacent is known to us. So you can easily calculate the tangent. So with the tangent, so can I write it here only? So let me write it here. So the tangent 28.5 is equal to x divided by 5. So I can rearrange that. I will get the x value. So the x value, I can easily get it from here. So the x is equal to 5 tangent 28.5. I will show you the values afterwards, all of them. So for a moment, the radius, so if I had to find out the radius, is come out to be 1. I had to add the 1 to it. Do not forget that one. So this is the 1 meter plus the x value that I get it. This is the x value. So this is 5 tangent 28.5. So just calculate this one, you will get your answer. So if I had to tell you this calculation, if I do this whole calculation, it is come out to be, this is the idea. I will share that PDF with you. So, but right now this is 1.1 plus 5 tangent 25, and that is 3 point, that is approximate 3.71 meter. So this is the radius, and from there you can find out the whole, how much the distance is being traveled in a one circular path. So that the speed, because the linear speed that we had to find it out, I'm going to call it, that is the V, that is the distance that being covered in a one circular path divided with the time taken to complete one, and that is already given, the time period is already given to us. So just 2 pi r is the total distance that being traveled, and divided with the time taken is 5.2 seconds. And if you calculate all these values, if you plug in all the values, and then it come out to be 4.5 meter per second. So that is the value that you will get. The same problem can be thinking in a different way. The V is equal to R omega. If you know that omega is the angular velocity, that omega is nothing but 2 pi radian, that is the 360. 2 pi is the 360 divided with the time taken to complete that. This is the omega. So as you plug in that, again the same thing, 2 pi r, omega value is 2 pi that I plug in, divided by the t value. So this is again V is equal to 2 pi r by t. So here also we had a 2 pi. So the same logic, even you can think it this way. The question. So determine the tension in each of the rope that supports the acrobat. Okay, so the tension force, we had to be determine the tension force, how much the tension force is. Okay, for that one, I want to first discuss what is the free body diagram of that one. So if I had to be make it, so let's look into that first for a moment. So there is a tension force that is holding that one. So that the person is moving around that. So there is a tension force in the string. As we know that tension force is in the string. So for a moment, let's stop the person at this. So this are, let's suppose that this is a person, that is acrobats that are moving in a circle around. So now, so let's look into the free body diagram. What is that free body diagram is? FBD, we call it in the short form, that the all the forces that are acting on a single body in with their respective direction and their angles, we had to be label them. And what is the magnitude of that? We had to represent that. So let's try to show the all the forces acting on this ball for a moment, but in the question it is acrobat. So let's downward force, vertically downward, that is the weight of the ball. So, or we can say that the weight is the mg force, mass of the ball into g. So in that case, there is a mass of the person into g, that is the weight of that the gravity is pulling that, obviously. Now we have the tension force, that within this respective direction there is a tension force. Then, so in that case, the angles are different, but for a moment, this is 53 angle, 53 degree. So I can, so this is the free body diagram. I'm just trying to split the component to equate the things are, okay. So for that, so there is a tension force. So this is the angle 53. So according to that, if they are the two parallel lines and one line intersecting that, this angle is equal to this. These are alternate. If this is x, this is also x. These are alternate interior angles. So alternate interior angle are equal if they are the two parallel lines. So this is 53. So this is also 53. I'm just telling you the idea how you are going to solve this question. Now, what I'm going to do is I'm going to split the component. So now the tension force is easy for me to split that one. So, and so tension force, I'm going to split into the horizontal and the vertical direction. You must know the vector resolution, how to resolve the vector. You can think it like this, Yeah, the R is the vector. If I had to basic give the idea to you, R is the vector. To split the component in the X direction and the Y direction. So this is the, let me call it, this is Rx. Let's suppose I mentioned this is the theta. This is the Ry. So we had to be find out Rx and the Ry. These are we call it component of the vectors. So to do that one, I'm going to do, okay, so let me change the color. Okay. Now this is the R component. To find out the Rx, just think it which trigonometry function I'm going to use. This R is the resultant vector is known. I'm going to split that. Let's suppose this is the resultant vector. We always split the component into the vertical. One is horizontal, one is vertical component. So this is the R vector and I'm going to split that. To use this is we call it resolution of the vector. This is the R vector. I'm going to split that Rx. So the Rx is basically for that I can use the cos theta. Cos theta is Rx adjacent to that one and the hypotenuse that is known to us. So here also the resultant is known to us. T is the known to us and we had to split that. So and in this case the Rx is come out to be R cos theta. This is the R cos theta component. In the same way, to find out the Ry, this is the opposite of that one. So I'm going to use the sine theta. Sine theta is Ry and by R, hypotenuse. So that is come out to be Ry means that the side that is opposite to that. So that is come out to be that the opposite of that, a resultant vector that is come out to be um, r sine theta. So r cos theta and the r sine theta. This is vertical component. This is whole splitting the component. Simple. So in the same way, always remember it towards the angle because this side is adjacent to the tension. So this is adjacent. For the adjacent, we use the cos. So in this, I'm going to split that in this. So what is the component is going to become of the tension force? So T cos theta component. And T cos theta is going to be balance the mg force. I will come to that point. So, and there is towards the center, there is a force that if I'm going to split that, correct? So we are trying to split into the vertical and horizontal. So this is come out to be T sine theta component. So if you had to be better understand this, you can make it the right angle triangle up means that this right angle triangle, you can make it the right angle triangle on the top of that. So if I had to explain you, so you can make it like this. This is the T hypotenuse, uh, tension and the theta over there. So you can, then you can use, this is, let's suppose this is the T y component. I have to find it out. This is the T x component and whatever the T x here is, so I'm going to take it the same way. So this is the logic is. So Ty here the cos theta because the angle is given the upside. So you can use that one. So hopefully you get the basic idea of that one. So till now. So let's try to draw the free body diagram in the question we have it. So in the question, what we have it is this question and this is the weight mg force that is acting downward, the force that is as whatever the question that mention it. So this is the tension force T. This is the tension by the way. So I'm going to write the component. So let me write it first more proper way. So okay. This is the 28.5 and let's go, this is the tension force. This is the free body diagram for this person. That is the all the forces are acting on that. So I'm going to, I should not make too big one because it resembles to be wrong, but I think you get the point. This is 28 So I'm rubbing that because otherwise the diagram become too messed up. So I had to make that much only, because I had to ultimately show that the magnitude had to be balance it out. So this is the theta. Remember it. This is the tension. So this is the tension T cos theta component come out to be. And this is the towards the center. This is the T sine theta component. Now let me tell you the logic. So because the person is not going up or the down, it is moving in a circular arc horizontally. So it means that mg force have to be the downward force, vertically downward force have to be equate to the vertically upward force. So for that, the one equation that I can make it over there is, so let me write it on the separate one. One is T cos theta, that is acting it upward tension force, that is equal to the mg. This is the one of the expression that I get. And from there you can find the tension force, because you have to calculate the tension force. To tension force, mg cos theta, everything is known to you. Mass of the person, that is 85, I think, and the tension force and the g value. So m is known to you, g value is 9.8, and force is theta is 28.5. So the tension force is known to you. Then this is the one way to do that. This is the first method one. So what is that method? Second is, so if you know the centripetal idea, centripetal force, what is the centripetal force? The net inward force that is acting towards the center, towards the center, that is centripetal force. So in this case, if I had to again show to you, so if I, okay, so in this case, let's try to, this is the center of the about which the things are revolving. So according to that, the whatever the component we split it, if you remember that this is the T sine theta. So T sine theta is acting toward the center. So that is the definition of centripetal forces. So what the centripetal force is, definition is the net force acting toward the center. So that is centripetal force. So uh, centripetal force is the F net toward the center. This is, we call it centripetal force. What is the net force that is acting toward the center right now? That is the T sine theta. So this is another way to do this question is T sine theta you can equate to the centripetal force. Centripetal force value is mv square by r. That is toward the center. That is another way to think it. And v is, we just calculated in the first part. Mass is known, radius is, we have already calculated in the first part. So divide with the tangent theta, sine theta, and you will get that. So this is the another method. So my point is T sine theta is acting toward the center, that is mv square by r. And the tension force you can calculate from there also. Everything is known to you. This is another way. Let's talk about method 3. What is the method third is to do this the same questions. Now because net force, if you realize that one, so let's draw the free body diagram here. The mg force is here. Upward force is T cos theta, because we already done the splitting the component. T sine theta. What is the value of T cos theta? Because if we combine this and this, you will get this vector, resultant vector. And that resultant vector is the T only. Correct. The resultant vector is the T, tension force. That is only they are asking in the question. So tension force can be written as, because again applying the Pythagoras theorem, T cos theta, T sin theta. So T cos theta square plus square root of that one I'm making, T sin square theta. Correct? Now, because T cos theta is equal to mg force, downward force, plus T sin theta is mv square by r. You can calculate this way. Do not forget to put the square. And again, you will get the same answer. So this is the way. These are the three ways that you can do. So, and the teacher will allot you the marks for that. So if I go further, so this is the B part that we have it. Okay, so you can look into that, the how we calculated the values and what are the values are. And tension force value have to be like this. So these are the three ways. Question. Discuss the consequences of the forces acting on the pole when one aerobat has the much greater mass than the other one. So what is going to be happen due to that one is, so one of the aerobat had a more mass. So due to that, so if you go to the free body diagram, so if the aerobat had a one more mass, so let's suppose this had a more mass than this one. So if it had a more mass, obviously one side, so the more tension force will increase, correct? Because the, so you can think it like this, because the mg is equal to T cos theta. Eventually, the angle is not going to be changed, by the way. So angle is going to be remain the same, but this, due to that, what is going to be happen? The mg force has increased, so the tension T cos theta value will increase. Due to that, the T value eventually is going to be increased because theta is the fixed one. So theta is not going to be changed. Due to that, theta doesn't depend upon the mass of that. So this component, basically tension force will increase. Due to that, one of the side we have the more tension force, one of the side we have on the motor, we have it the less tension force. Due to that, there is a torque, means there is a more force here on this side, there is a less force on the other side. So there is unbalanced one. So this is only that you have to mention it in that part. If you had to read it out more clearly, the answer is for that one, you can write it like this. So vertical compression on the pole increases. Horizontal forces become unbalanced is because of the, we had the one of the side is more one, another one is less one. So due to that, the tension force component have to be increased on the one of the side, another side. If you take the horizontal component is going to be unbalanced. So providing the net lateral force and bending the movement, and that lead to the tilt the platform towards the heavier aerobat. So because on the one of the side the tension force has increased, so this is the more tension force on this side. So one more tension on this side the less tension force. So this platform is going to be slightly tilt on the higher side. So this is the impact due to that. Thank you. Have a good day.